Good afternoon everyone, I'm Suzanne Higgins and this is Lisa Black. So we're going to be talking about soil health and the importance of measuring and monitoring soil health on your farm. So whenever your soil is healthy, your nutrient use efficiency will improve, so you'll get greater value from the fertiliser and slurry you apply, and also your soils will be more resilient to climate extremes. So whenever we talk about soil health, we're talking about the physical, the chemical and the biological properties of your soil. So we would measure soil health by a number of indicators. In terms of chemical indicators, we're talking about the pH of the soil, the nutrient status, and the amount of organic matter in the soil. So currently, the Northern Ireland Soil Nutrient Health Scheme is measuring soil chemical indicators in every field across Northern Ireland over a 4-year period. So this is giving farmers information on the pH of every field and the nutrients of every field in terms of phosphorus, potassium, magnesium and sulphur, and also the organic matter status of their fields in terms of the carbon stocks of the soil and the carbon stocks of the above ground biomass, which is the trees and the hedgerows on your farm. Through the Soil Nutrient Health Scheme, you also get fertiliser recommendations, and these tell you recommendations of how much fertiliser and slurry you need to apply for optimum growth. So the key thing for nutrients is just to apply the amount you need, no more and no less. So if you apply too many nutrients, there's greater risk of some of those nutrients being lost to the environment. And also you're just putting on fertiliser that you don't actually need. Likewise, if you put on too little nutrients, there's a risk of nutrient deficiency, which is equally undesirable. So the key thing is to follow your fertiliser recommendations and just put on just as much nutrient as you need and no more, no less. In terms of soil pH then, so soil pH is one of our most important soil health parameters. It regulates a lot of the processes within the soil, the biological activity and the nutrient uptake. It's really important to monitor your soil pH and to get it right. So for a permanent grassland field, the recommended pH is 6.2. If you're growing clover or multi-species, the recommended pH is slightly higher, up to 6.5. And if you're farming in a peaty soil area, the soil will be naturally more acidic and the pH could be sitting around 5.5. So we recommend that you apply lime more regularly, little and often, like every 4 or 5 years, instead of big gaps of 10 years or more between lime applications. It's better to try and stay close to that optimum pH for as much of the time as possible in terms of your overall soil health and your productivity. I'm now going to talk about soil physical properties. So in terms of physical health, we're talking about the structure of your soil, the amount of oxygen in it, and how well it drains after rainfall. So what we want to avoid in terms of physical health is any soil compaction. So whenever your soil is compacted, it's compressed, so there's less oxygen in it and the water can't drain freely through it. So signs of compaction on your farm, you might see after rainfall, the water just lying on the surface, it can't drain through the soil. You may have parts of your field which frequently flood. This could be a sign that part of the field is compacted or the whole field is compacted. Also, you get areas of patchy growth, and you usually see this where there's tram lines where you've been passing over with vehicles. Very often in the gateways and the headlands of fields, there is a lot of compacted soil just because of the amount of passes you make of the field and with your machinery. And that usually the soil is compacted in these areas and there'll be less growth. You may also see that the soil can sometimes get a sticky or cloddy appearance. It can be even grey in colour, slightly greyish colour, which means there's less oxygen in it. So we want to try and reduce compaction where possible. Some surface compaction is fine, that's normal. Most fields will have a bit of surface compaction, that's fine and that will recover. The problem is if you get very deep compaction in your soil and you have to either subsoil or totally reseed, which is very expensive and it's hard to get a window of opportunity to reseed or do any deep subsoiling. So that's kind of something we want to try and avoid where possible. And we see soil compaction as becoming a bigger threat in the next few years just because of the weather we're having. So this particular winter, very, very wet into the spring. The last few years, very, very wet spring conditions. Very hard to get out and put out slurry. Like this year, it was wet to April, May. The soil was just saturated. Very hard to get out with your grazing animals. If you went out with a slurry tanker and your soil was too wet, or if you put out grazing animals, you'd actually can cause quite a lot of damage to the soil, which takes a bit of time to recover from, and it would be affecting your yields for that season. So we want to try and avoid damaging the soil where possible, and we just know that this is very difficult with the amount of rainfall we're having. So in AFBI, we are looking at soil compaction. We're looking at how we can manage our soils going forward with the climate we have. If we keep getting these wetter winters, particularly into the springtime, what can we do, you know, to manage the land? How do we get our slurry out without damaging the soil? How do we get animals out? These are the kind of things we're looking at now in our research. Because of the way the weather patterns are going, we're trying to look at solutions to this. So your soil physical properties, they interact with the chemical properties of the soil and the soil biology. So all these things all interact. And I'm going to pass on to Lisa now, who's going to tell you about soil biology.
Okay, soil biology. So soil is a living substrate, and every small amount of soil has hundreds of thousands of microbes in it, bacteria and fungi. And it also has a lot of soil animals as well, of all sorts of shapes and sizes. Probably the largest you will find are earthworms. Because it is living, it's very susceptible to changes in the environment. So it responds very quickly to changes in temperature, changes in moisture, etc. So actually measuring soil biology can be quite problematic. And this is an area that AFBI has been working on to try and find the right parameters, the right ways to measure soil health for Northern Irish soils. What we have found so far is that soil biology is very much correlated to pH. So Suzanne's talked about how pH is really important for chemistry. It's really important for biology as well. So I think one of the key things you can do for soil health is to get the soil pH right. Another fact we found really related to soil biology is the carbon, which isn't surprising given that carbon is in all life forms. So maintaining carbon in soil is a really good way to try and support soil biology. So how do we measure soil health, biological soil health on farm? An easy way or a good starting point is to look at earthworm numbers. And the HDB have produced guidelines for how many earthworms you would get in a 20 by 20 by 20 pit of soil. So their recommendation is to dig 2 or 3 pits across a field, maybe more depending on the size of the field, hand sort that soil and count the number of worms in that amount of soil and create an average for those fields. And you could do that across different fields if you have different management in the different fields, or the fields are looking to be performing differently. And that will give an indication of the biological health of that soil. So on the left here, we have figures from the HDB Soil Health Scorecard for grassland soils. And if you have less than 9, the recommendation is that that's not good. Red is never good. So less than 9, you really need to investigate the condition of the soil. 10 to 19, it's not disastrous, but it could be better. Over 20 is a good place to be, and that's the green there. But it does say monitor because obviously you want to maintain that. So the middle chart here shows the numbers of earthworms we've had in about 50 soils in Northern Ireland, 50 grassland soils, and it's split out by years from reseeding. So the 5 to 8 there has a count of 11, so really that could be better. It's saying review. 9 to 10 is 29, so that's excellent, and over 10 is coming in at 20. So I suppose, why are those figures like that? Less than 8 could potentially be due to recent reseeding disrupting the biology of the soil, and over 10 could be due to potential compaction due to the age of the sward. So key messages from this second stop. Obviously, soil health is dependent on biology, physics and chemistry, and we are creating databases of the different parameters of those soil health indicators for a range of soils across Northern Ireland and different land uses. And if we get soil health right, it means that the soil is functioning well. It also means you're going to get better nutrient use efficiency, and that's good for the environment and also from a business perspective as well. and it also makes soils more resilient to climate extremes. And how we manage the land really does impact on soil health. So the inputs we use, whether that's inorganic fertiliser, organic fertilisers, other chemicals, ploughing and reseeding all will impact. And as I said, AFBI scientists are focusing on all aspects of soil health. The Soil Nutrient Health Scheme is very much focused on the chemistry, whereas there's other work going on soil physics and the soil biological health. If you want to go and read any more information on aspects of this topic, there's posters in the soil and plant focus area. So if you have any questions, we're happy to try and answer, and thank you very much.